Hi, my name is Ben Seung Yong and I'm going to show you a demonstrator which we have built on distributed learning with IoT using multi-agent system and Bayesian autoencoders for quality control in manufacturing. This work is part of the Pitchin project, which is a collaboration between universities of Sheffield, Newcastle, Oxford and Cambridge together with industrial and commercial partners to deliver benefits by significantly enhancing Internet of Things innovation. The current state of quality control in manufacturing involves time-consuming manual inspection procedures and also traditional statistical process control methods which are not adaptive and less accurate in complex multi-stage processes. Consider a multi-stage manufacturing process which is complex with many machines and parameters, and we obtain data from an actual production line near Detroit, Michigan provided by Lifeline Technologies. The raw materials are firstly fed to machines 1, 2, and 3 in the first stage before feeding them to the combiner, and in the second stage they are processed by the machines 4 and 5, and lastly we get the manufactured product. Now, with the use of IoT and AI, can we improve upon the quality inspection of multi-stage processes and quantify uncertainties? Can we also determine which machines and parameters are contributing to the defect of any products? Hence, we propose our IoT and AI solutions. Firstly, we have developed a multi-agent system testbed, which is a flexible IoT data pipeline for multi-stage manufacturing process. And secondly, we have also developed Bayesian autoencoder, which is a novel deep learning algorithm with uncertainty quantification. Now let's get started with the demonstrator. There are three main steps which I would like you to follow. Firstly, is setting up the agents pipeline. Secondly, we analyze and compare the machine learning models. We are going to use a novel deep learning model which we have developed here called Bayesian autoencoders. And lastly, we will deploy and visualize real-time predictions. Now let's get started. There's nothing on the screen yet because it's quite an empty and blank state. So let's add some agents. And we add in a data stream agent, and we can actually set the name of the agent. Let's set it to process stage 1 agent data. And here we can select the input stage which it reflects and put 1, and this is actually a multi-stage process, products going in multiple stages, and we select also the training size and we add agent. Here we have a single agent now. Now let's add another BAE agent, which stands for Bayesian autoencoders, and these are the parameters, the number of nodes in the deep learning model, such as 500, and we have a decreasing number to reflect a bottleneck kind of architecture. So we have 500 nodes in the first layer, 300 nodes in the second layer, and then we have 50 nodes in the third latent dimensions layer, which is the bottleneck. There are a number of likelihoods which you can select. Select the learning rate and the number of samples which we would like to train, and number of epochs, and then we add the agent into the network. And now we have two agents, but they are not connected, right? On the right hand panel, we'll select the select output module and we can connect them together. Process stage 1 data is actually streaming to the BAE agent. We'll actually add a few more agents. For example, the evaluate agent will evaluate how accurate the model actually is. Connect the BAE to the evaluate agent. We also add a coalition, which groups the agents together to be more systematic about this. And now we have an empty coalition, which don't have any members in it. Let's add all of them into the coalition. See, all of these agents are actually now grouped under this coalition. We can actually click on Start. Now we go to the next page of ML experiment, where we can look at the results of training BAE agents on the process data. So there's quite a lot of data to look at here. But no worries, we can actually filter to the things that we are actually interested in. For example, we are only interested in AUROC. There are actually not a lot of comparisons that we can actually do currently because we have only trained one model. So let's go back to the agent network and we set up more agent pipelines to be trained and compared. And this is the agent network which I have set up, and we can actually rearrange these agents to be more intuitive to the eye. Now what we have here is the process stage 1 pouring in predictions to the plotting agent from the BAE agent and sending it to the monitor agent. The same goes to process stage 2, which pours in the predictions to the plotting agent and the monitor agent. Alright, I have conducted many more experiments, and now I would like to compare the different results of the models. And in this giant table, we will only filter on the performance matrix which you are interested in, which is AUROC with the negative log likelihood. And we can actually see that Bernoulli likelihood perform worse than Gaussian likelihood in anomaly detection. For the stage 2, we actually score lower than that of the stage 1 prediction because it is a more noisy process and a harder process to be predicted. Now that we have decided and compared different models and chosen the best ones, we are ready to deploy them. Now when we scroll down, we can actually see this graph which shows the predictions of the BAE agent on the products that are being manufactured. So on the x-axis we have the product number that are incoming, and the y-axis shows the prediction of the BAE agent, which shows the log likelihood, where more positive shows that it is a positive outcome and negative shows that it is likely to be an anomaly and a faulty product, for example. Then you can actually see that there are occasionally quite a number of spikes in the predictions. Now in the latest ones we have quite a huge dip in process stage 1, which is shown by the blue lines, and this is very likely to be a fault in the manufacturing process which requires more investigation. And so by looking at this chart, we can actually see which machines are actually contributing most to the log likelihood or the anomaly prediction that we have. The green bars actually show that they are within tolerance of our predictions, and red bars actually show that they are out of tolerance. This can actually give us information for the operators to look and inspect them more carefully to improve the quality process. That is all for our demonstration of how we can actually use the agent-based framework which we have developed, and there are 3 main steps. Firstly, we set up the agents pipeline, then we analyze and compare the machine learning or Bayesian autoencoders model, and once we are satisfied with them, we move on to the last step, which is deployment and visualization in real time. Thank you.